Alright, today we're talking about adding polynomials. Okay, we're starting new. This is a new 9 weeks, a new chance to kick butt. Alright, so adding polynomials. Pretty simple. You've done it plenty of times in the past. Let's review. So a polynomial is an expression with at least 2 unique terms, positive whole number exponents, and no variables in the denominator. Okay, what this means, let's look at an example. One example could be 3x squared plus 4x minus 5. So at least 2 unique terms. Well, a term is what number is separated by plus or minus signs, basically. So here we have 1 term, 2 terms, 3 terms. They're unique because this one's x squared, this one's x, and this one doesn't have any x. Okay, which means you can't combine them. So you have 3 unique terms. Sorry about my voice, I've kind of lost it. They're positive whole number exponents. So my exponent of 2 that's on my x, it's positive, it's a whole number. On this x, you don't see an exponent, but you know there's really a 1 there. Okay, so it's positive whole numbers, no exponents, really a 1. And then no variables in the denominator, meaning if I had a fraction, so let's look at another example. Let's say I had 3x squared plus 2 let's mix it up because we have 3x right there. 3x cubed plus 2 divided by 5. The bottom of your fraction is your denominator. I don't have any variables in my denominator. I don't have like an x down here, so we're good. Degree of a polynomial is the largest exponent in the polynomial. So if we're looking at this example right here, 6x to the 4th plus 2x squared minus 3. The exponents I have are a 4, a 2, and a 1. The largest exponent I have is the 4. So this would be a degree of 4. So if I was to talk about the degree individually of just one single term, 6x to the 4th has a degree of 4, right? 2x squared is a degree of 2, and then negative 3 or minus 3 is a degree of 1. But as a polynomial, it has a degree of 4, okay? So for combining like terms, it's as if terms have the same degree or the same exponent. Then we can add or subtract them together, okay? So if we're looking here, the only ones that have the same exponent would be 4x squared and a minus 3x squared. Those would be the only ones that you could add together, okay? So if we were to add both of these expressions together, I'm going to look for my largest degree. I'm going to look for my largest exponent. So my largest exponent is this x to the 4th, so I'm going to write that one first. So I'm going to say 2x to the 4th because I couldn't combine it with anything. Then I look for my next largest exponent, which would be my x's squared. So then I would say 4x squared minus the 3x squared, which gives me just a 1x squared. And then next I'm left with plus 5. And we'll look at more examples like this in a second. Oops. Okay, briefly I just told you that we want to list our expressions from largest exponent to smallest. Most of the time it's already going to be done for you, but not always, okay? So one thing I like to do is I like to circle like terms as I go. So I have a 7x to second power and a 2y, oh not 7x, 7y to the second power and a 2y to the second power. So they're both positive. We're adding both, right? We're adding this term plus this term. So 7y squared plus 2y squared gives me a 9y squared. Then next, you could box them to differentiate. You can X out the ones that you've already done. So we have a 4y plus a positive, 5y, which gives me a positive 5y. And then next I could underline, or you could heart, or you could star, whatever you want to do. So I have a positive 3 plus a positive 5, which gives me a positive 8. And there would be your answer. These are unique terms, so you can't combine them. You can't combine a y squared with just a y, or a term without variables. Another way you could do it is you could change the orientation. So instead of writing them out sideways, you could list them out on top of each other. So then match up with the 2y squared under the y squared, the y under the y, and the 5 under the 3. And you could add it that way. So you can see 9y squared plus 5y plus 8. And same thing. For example 2, notice they're also already in order from greatest exponent to smallest, right? So either way you could do it. Let's do it this way first this time. So we have a 4k squared minus 3k plus 1. And then I'm going to list this one underneath. They're being added. So I'm adding these together. I should have put that there. And then I have a negative 3k squared and a plus 5. I'm not going to put the 5 here because this is my k column, right? My k squared, k's, and then my terms without variables, which are called constants. So 4k squared minus or plus a negative 3k squared gives me a 1k squared. I would just bring this minus 3k down, and 1 plus a 5 gives me 6. Right? And if you like it the other way, we're combining these, they're being added, so 4k squared minus 3k squared is just a 1k squared. You don't have, I said box this one, you don't have anything to go with this one, so this one just comes down as it is. And then 1 plus 5 is 6. For this one, if you notice, it's out of order. Okay, so that's fine, but in the end, when you write out your answer, you want them in order. If you'd like to rearrange them from the beginning, that's fine too, okay? So if you do it, we'll do this way to start. So let's see. We'd want to rearrange it from the beginning. So this is a minus 3x squared or a negative 3x squared plus 7x plus 11. And then we're adding these two together. My 6x is positive, and it's going to go under my 7x. My negative 13 is going to go here. And then my positive 2x squared is going to go there. So we have negative 3x squared plus 2x squared, which gives me a negative x squared. 7x plus 6x gives me 13x. And 11 minus 13 is a negative 2. Okay. The other way you would do it would be you just look for your largest exponents. So I have a negative 3x squared. The sign in front has to stay with it. A negative 3x squared plus a positive 2x squared, which gives us that negative x squared. Positive 7x is positive. And a positive 6x gives me a positive 13x. And then negative 13 plus 11, or 11 plus a negative 13 gives me a negative 2. Okay, now we want to look at adding polynomials for the perimeter, okay? So if you remember what perimeter is, it's just adding all of the sides together. So our first example, we're just looking at this triangle. Okay, if we want to find the perimeter, we're going to add all of the sides together. Each side is an expression, so you're just adding the like terms, or the terms with the same exponents or same degrees together, okay? Two ways you could do this. One way, list all the sides out. So you have 10c plus 4 you have 6c plus 4. So lining up all the c's over each other and all the terms without variables over each other. And then we have 8c plus 1, okay? So then let's add them all up. 4 plus 4 plus 1. 4 plus 4 is 8, plus 1 is 9. 10c plus 6c is 16c. 16c plus 8c gives us 24c. And a positive 9. So that'd be your answer. The other way to do it is just the circle box, underline, all that kind of stuff. 10c plus 6c is 16c. 16c plus 8c gives us 24c. And then 4 plus 4 plus 1 gives us plus 9. Either way, whatever method you prefer and makes more sense to you. One more example and we're done. All right, find the perimeter. So we have 4x minus 1, x plus 3, and we have, this is a rectangle. Okay, so we're finding the perimeter of the rectangle. So we want to add up all the sides. Here's where people mess up. They just add these two sides. But a rectangle has 4 sides. Okay, yes, you're only given 2, but if you know about rectangles, you know opposite sides are the same. Okay, which would mean this side is also a length of 4x minus 1. And this side is also a length of x plus 3. Okay, so once we've done that, now we can find the perimeter by adding up all the sides. Okay, so we can list it out. 4x minus 1, x plus 3, 4x minus 1, and an x plus 3. A negative 1 plus 3 and minus 1 plus 3. Negative 1 plus 3 would be 2. 2 minus 1 is 1. And 1 plus 3 gives us 4. Okay. Another way you could kind of do that is see that you have 6 positives and 2 negatives, and 6 minus 2 gives you 4. 4x plus 1x is 5x. 5x plus 4x is 9x. And 9x plus 1x gives us 10x. And that was a positive 4. Or once again, circle 1x plus 4x plus 1x plus 4x gives us 10x. We've done those. And then a positive 3x minus 1 plus 3 minus 1 we know gives us a positive 4.